Item discrimination analysis of multiple choice questions exam in SPSS using data extracted from student exam results. The item discrimination, the ID, will be calculated using the Kelley's methods. Item discrimination, abbreviated ID, is a method proposed by Kelley in 1939. It is a measure of whether an item, which is a question in this case, distinguishes between students who learned the subject content well and students who did not. The measure is based on the comparison of performance between excellent and poor students in the exam as a whole. The item discrimination is calculated by arranging the student total score from the test in a descending order. Group the students based on their scores into upper group and lower group. The upper group contains the top 27% of overall scores, and the lower group includes the lowest 27% of overall scores. Count the number of the correct items in the upper group, and then count the number of the correct items in the lower group. Then subtract the correct questions in the bottom group from the correct questions in the top group. Then use the Kelley's formula to calculate the item discrimination as given here. The ID equal to upper group minus lower group divided by 27% of total students, i.e. calculating the upper group proportion and the lower group proportion and subtracting them to get the ID. An ID percentage also can be calculated by multiplying the ID product with 100. Now, the item discrimination values range from -1 to +1 based on the equation of Kelley's. The outcome of the calculation have a range of -1 to +1. Positive value of +1 indicates that the item is discriminating between high performer and low performers, and +1 indicates a perfectly discriminating item. Zero value means that the item is not discriminating between high performers and low performers. On the other hand, negative value of -1 means that the item discriminates perfectly, except that low performing students answering item correctly and high performing student answering it wrongly. As shown here in the table, the range for the ID value is listed, and the items are classified as either bad item when the ID value is from 0 to 0.24, that is based on Kelley's formula. Good item when the value is between 0.25 to 0.39. Excellent item when the value is between 0.4 and 1. If the ID value is minus, then the item is very bad and it is recommended to remove and exclude the item from the exam or the test. Item discrimination analysis in SPSS based on Kelley's equation. The analysis will evaluate and identify multiple choice exam questions that are good or bad in discriminating between high performing students and low performing students. So this analysis is only designed for multiple choice questions, and the analysis is based on an equation generated by Kelley's to determine the item discrimination or the question discrimination. And the way to do that is to calculate the total scores for each individual participant achieved in an exam, and then group the student into an upper group and a lower group. The upper group contains top 27% of the total score, and the lower group includes lowest 27% of student total scores. And then proportion can be calculated for the upper and the lower, and a percentage can be generated for each individual item or question. And the value for the item discrimination can be from -1 to +1. Here in this SPSS data view, I have a result from exam and the test for 20 students participated in this exam that included in it 20 questions, 20 multiple choice questions from 1 to 20. And each individual student answered the multiple choice questions, and their answers are recorded as either 0 or 1, given a value of 0 or 1. 0 represent wrong answer, 1 represent correct answer. And from those 20 questions, we aim to determine which one of these questions are good questions and which are bad questions, in distinguishing between excellent students and low performing students. And to do the item discrimination analysis, it is a multi-step. The first step is to calculate the overall mark or the total mark achieved by each individual student, i.e. to add up all the correct answer recorded by each individual student, add them up and generate a new variable, call it total score. And to do that, we click on transform, compute variable. In this new window, I'm going to generate a target variable, call it total score. And in the total scores, I'm going to add all the values within each individual cell together. So i.e. add all these multiple variables for each individual student together to generate the total or overall mark. So we need to use the sum function in this case. And the sum function, to get the sum function, click on all, scroll down to statistical, and then click on sum, drag the sum command into the numeric expression. A numeric expression, the sum is followed by a bracket, so we need to enter or transfer each one of these questions or variables into the bracket or between the bracket, and separating each question by a comma. So if you click on the first one and then add a comma, click on the second one, transfer, comma, and then third one, and so on. And since we have here 20 exam questions, I had already generated these questions labels in Word document, type them, and I'm going just to select them and copy them, and then insert them or place them in between the brackets. So if I delete that, add the bracket again, and Control V or paste. So all the 20 variables have been placed in between the brackets, separated by a comma, and this will instruct the software to add all the values for each individual student, to add them up together and generate a new variable called total score. If we click on OK, again we'll see here that a new variable is generated called total score that has in it the overall mark achieved by each individual student. And I'm going just to edit the column a little bit by removing the decimal point and making it 0, making it at the center, and then since it is a marks and this is a scale, it's measured at a scale, and then I'm going to reduce this, keep this up to 66, so to reduce the column. So now to continue with the item discrimination analysis, we need to rank those overall mark or scores in a descending order from high to low. So we're going to click on data, sort cases, and we are going to sort the cases by the total score and in a descending order from high to low. Again, as we can see here, the data are rearranged that we have the highest score achieved by student are 17 out of 20 and the lowest is 8 out of 20. The next step in SPSS is to rearrange the data to be able to manage to calculate the upper group and the lower group. So we are going to use a function called transpose, in which we transpose these questions from being in a column into a row and swap the students' numbers and IDs, swap them from rows into columns. So it is a reciprocal swapping. So if we click on data, scroll to transpose, and then we are going to transpose all the variables with even the total score into the box of variable, and we're going to name the variable, move the student ID into name variable, and if we click on OK, a new window appears showing that the questions has been transposed into rows and student IDs had been transposed into columns. Again, as this is for question number 1, 3, 9, 19, and 2, similar to the original 1, 3, 9, 19. It's just only it has been transposed. I'm going to do a little bit of editing here as the width of the column is large, so I'm going to reduce it a little bit to do a little bit of editing. So I'm going to change first of all the decimal into 0 for the copy for all the data we have here, for the value of the value or the scores within each cell. And I'm going also to change the column width as it's too high for 12, so we'll keep it at 6, give it a 6, and this is also 6. and see if I can copy it, and if I can drag it and change it for all, if I click Control V, again it has changed the column to number 6, and again align them into the center, so keeping the data within the center of the cells. And for measurement, we're going to change that into scale. For all the data. So when we look at the data view, it is much neater and much better. We could reduce it more, but that's more than sufficient. Again, if we look at the total score, the order and the rank is kept also constant, hasn't been changed since we have done the ranking. So now we have first of all calculated the total score, ranked the data, and then transpose the data. The next step is to group these students into upper group and lower group and calculate the proportion in each. And for the upper group, it should contain top 27% of the student total scores, and the lower group contain lowest 27% of the total score. And since we have here 20 students, and if you use a calculator, though we don't need a calculator, it's just only we have here 20 students, and we need to generate a group that has 25%. So we will multiply that by 27%. That will generate 5.4. So we will convert that to integer. So we will put in the upper group 6 scores, overall scores from 6 students, and in the lower one overall scores from 6 students, again in the low performing student. So in this case, so we're going to generate upper group that includes 6 overall grade from 6 students, and the lower one overall grade from another 6 students that are performing poorly. And the way to do that is to generate again here a variable, call it upper group, lower group. So compute variable, generate a target variable, call it upper group, and the upper group, again we can see here the order is and the rank is kept in place. So K1, as we can see here, is the highest mark or the highest total score here. The first 6 has the highest total score, so we're going to select 6 from K1, 1, 2, 3, 4, 5, 6 up to K4 here. So what we will do here is to click on brackets here, move the first value from the variable K1, and then add a plus sign, then add the second one, and then another plus sign, a third one, a fourth one, a fifth one, a sixth one. So we have here top grade or top overall scored from the top performing students. So this is the upper group, and we're going, since we have selected 6 students, divide that by 6, and if we click on OK, a variable generated here for the upper group for all the 20 students and the 20 questions. Now, to generate the lower group, we're going to do the same thing, but we're going to select the lowest 6 scores. So here are the lowest 6 from 1, 2, 3, 4, 5, 6. So we're starting with 7, moving 7, adding plus sign, and then this variable, plus sign, this variable, and then the next one. We haven't moved the 11th. And then we move the other one. And then the next one, and finally the last one. So we have here 1, 2, 3, 4, 5, 6 variables moved into between the bracket, and we need to add them up and then divide them by 6 to generate the lower group. So here we are calculating the lower group, and if you click on OK, and again another variable is generated called lower group. The next step in generating and calculating the item discriminating IT is to subtract the value from the lower group from the upper group. And again, to do that, we click on compute variable, and I'm going to reset that and call it ID. And instead of retyping the whole thing, you just click on upper group, put the minus sign in between, and then lower group, and then click on OK, and ID or this item discrimination is generated here. We're going to ignore the value for the total score from our calculation, but what is genuine here is that this is the ID score, and the ID value should be between -1 to +1. So we could see 0 value here, and as we can see here, a 0 value, and a 0 value here, and a minus value here, and a positive value of 0.5. So if we take the first example here or the second one, -0.17. -0.17 indicate that there is something not correct with the question. The question is, in this question number, let's say, which question is this? Question number 2. Low performing students are answering the questions correctly, and high performing students are answering it wrongly. So this question has to be removed from the exam, as it is not discriminative. It does not distinguish between high performing and low performing. Now, the other thing is that also the question number 3 has a value of ID value of a 0, and that is indicate that this question is not discriminating between high performing or low performing, as they both scored the same on this analysis, ID analysis. Again, the same thing for question number 4. If we scroll down here, again, this is a question number 16, and if we show from question number 16, it has a positive value, and it is 0.83. This is a very high value, which indicates that this is a very good question, that it can discriminate between excellent students and poorly performing students. So anything, the rule for ID analysis, the rule for it, that anything above 0.25 up to 0.39 is considered to be a good question. anything above 40%, 0.4 and above is considered to be a extremely good question. So this question is extremely good. This question, again, this question, though it is positive, but the score or the value for it is 0.17, which is less than the standard. The standard for classifying questions has to be above 0.25 and above to 0.39, but in this case it is below 0.25. Thus, this question is a poor question in discriminating between high performing and low performing. So this question is poor questions. This question is a poor one. This one is a good one, very good one, very good one. This is good. This is bad one. This is good, very good, very good, good, and so on. So this is the way to do item discrimination analysis in SPSS for a multiple choice questions, and it is of a great benefit and use for those who designing an exam or an assessment for students and want to evaluate the power of discrimination of the questions and ability of the questions or the item to discriminate between high performing and low performing students. The way to do that is, one of the way to do that is to do an item discrimination analysis based on the formula formulated by Kelley's equation. So the way to do that is to rank your data into according to the overall scores from high to low, and then in SPSS rank them, first calculate the total, then rank them, then transpose your data, and then calculate the upper group proportion, lower group proportion, and then subtract them from each other to generate the ID. We could also, in addition to calculating the ID in this way, we can also generate an ID percentage. The way to do that is to go to compute again, and we are going to call it percentage. And to do the percentage is to select the ID, drag it here, and then multiply that by 100 to get a percentage for the item. Again, as we can see here, this item is 83% discriminative. So this is the way to do item discrimination analysis in SPSS using Kelley equation.